Howdy, and welcome to my video on trig functions. In this video, I will be going over problems from the Virtual Math Learning Center and just solving trig questions to teach some concepts. These problems were taken from the Virtual Math Learning Center, and a link to these problems will be in the description. Okay, so starting with the first question, we need to find the exact value of the 6 trig functions, given that the hypotenuse is 29 units long and the side opposite the angle is 21 units long. So the 6 trig functions, right? We have sine of theta, which is sine, right? Cosine, tangent, and then their reciprocals. So cosecant for sine, secant for cosine, and cotangent for tangent. Please note that secant, cosecant, and cotangent are not your inverse functions. Your inverse functions would be arcsine, arccosine, arctangent, and they give you the angle theta if you put in the value. But these reciprocal functions, as I call them, they still give you a value given an angle. It's just you switch the numerator and denominator as if you were doing the original, so sine, cosine, or tangent. So first what I'm going to do is I will draw my triangle. Okay. So I have my angle theta, and let's just say it's here. Okay. My hypotenuse is 29, and the side opposite is 21. Okay. Now, this missing side, right? We can use Pythagorean theorem. So 21 squared, and let's call this x, equals 29 squared. This is a special right triangle where it's 20, 21, 29. Okay. So a lot of times right triangles, there were certain side length combinations. The most famous one is probably 3, 4, 5, right? There's 5, 12, 13, and similar combinations. I can prove this real quick. So 20 squared is 400. 21 squared is 441. And I actually don't know what 29 squared is. 1, 8, 18, 26, 0, 5, 8. This gives me 841. And you can see that if I add these two up, I get 841. So my x here is 20. Okay. So again, this 29 is my hypotenuse. I'll put HYP for the abbreviation. For 20, this is my adjacent side. This is the side that is touching the angle. See, it's touching the angle. Well, it's not the hypotenuse. And then the side that doesn't touch the angle at all, that is my opposite, which I will call up, OPP. So SOHCAHTOA, right? SOHCAHTOA. Our sine is opposite over hypotenuse. Actually, don't use the colors. Sine is opposite over hypotenuse. For cosine, we have adjacent over hypotenuse. And for tangent, we have opposite over adjacent. Okay, that means for sine, we will have 21. Let me do fraction bars. For sine, we'll have 21 over 29. For cosine, we will have 20 over 29. For tangent, we will have 21 over 20. Sorry, 21 over 20. Now for secant, right, we just flip. So we flip the sine value over and we get 29 over 21. For secant, we flip cosine over, so we get 29 over 20. And for cotangent, we flip tangent around, so we get 20 over 21. And these are our answers for question 1. Okay, so for question 2, we're given a value for sine, and we're told it's in quadrant 1, and we need to find the following identities, like evaluate the functions, okay? So we need cosine, cotangent, cosecant, and tangent of the complementary angle. The first thing we can do right away is solve cosecant. As cosecant, you just take the reciprocal of sine, so you flip the numerator and the denominator, you get 7 over 4. Okay. But now from here, I need to use my triangle. So if I draw my unit circle, or I guess my graph, right? I'm in Q1, right? That means my cosine is positive, and my sine is also positive. So go like this. Okay. My angle theta is right here. Sine is opposite over hypotenuse, right? So my 4 is right here, and my 7 goes right here. Using Pythagorean theorem, we can solve for the missing side. So 4 squared plus, we'll say x squared, equals 7 squared. 16 plus x squared equals 49. X squared equals 33. X equals plus minus 33. And the question is, are we going plus 33 or negative 33? Since we are in quadrant 1, right, my side length is in the positive side of the x-axis, so we only want positive. So this should be root 33 as well. So my missing side length is a positive root 33. Okay. Cosine is adjacent over hypotenuse, so that gives us the square root of 33 over 7. Cotangent is the opposite of tangent. Tangent is opposite over adjacent, so cotangent is just adjacent over opposite. This gives us the square root of 33 over 4. Now, tangent of 90 minus theta, if you think about a triangle, right? The entire triangle has 180 degrees, right? Now, if we subtract 90 from, so let's say we want to find a missing angle, right? So we subtract 90 from the right angle, and we subtract theta, because that's our other angle, right? And we get 90 minus theta. What does this mean? It means the angle we're looking for is actually this one, right? And now for tangent, right? We have to redefine adjacent and opposite based on this new angle. So my opposite of this 90 minus theta is my pink side, my old adjacent, and my old opposite, right? What was the opposite of theta is now the adjacent of my 90 minus theta. Tangent is opposite over adjacent, so it will be square root of 33 over 4. Neatly enough, it's also equivalent to cotangent. Okay, and that is the answer to number 2. All right, so for number 3, we have a point on the ground that is 47 feet away from a tree. And the angle of elevation is 30 degrees, and we need to find the height of the tree. This means that when we have our tree, okay, a happy little tree, we have some point away, and we're told that it is 47 feet away. We need to find the height of this tree, and call it h, and the angle of elevation is 30. The angle of elevation means when you start from the ground, right? You start from the ground and then you go up 30 degrees, like this. And this gives you this line right here, right? Let me rechart this arrow a bit. There you go. So now we have our right triangle, right? And we need to find the exact height of the tree. Currently, our only information, right, is our opposite and our adjacent. If we think about the main 3 functions, right, like the original trio, so to say, the only one that uses both opposite and adjacent is tangent. So tangent, and in this case, it will be of 30 degrees. You have to specify degrees. If you don't put the degree sign, you will we will assume it's radians, which is an entirely different unit. Okay, this is equal to the opposite over adjacent, and this is h over 47. That means our h is 47 tangent of 30. But if you remember our unit circle, right? At 30 degrees, we have sine being equal to 1/2, and cosine is equal to root 3 over 2. Now, why is this relevant? Because h, right, sorry, tangent, right, being opposite over adjacent, it is also sine over cosine. That means my tangent at 30 degrees is equal to sine at 30 degrees over cosine at 30 degrees, which is equal to 1/2 over the square root of 3 over 2. We can multiply top bottom by 2, and we just get 1 over root 3. We can rationalize this by multiplying top bottom by the denominator, and we get root 3 over 3. Okay? That means our height is now equal to 47 times root 3 over 3. And our final height, or our most simplified height, is 47 root 3 over 3. It is expected that if you have an angle that's directly on the unit circle, so 30 degrees, 45, 60 degrees, pi over 6, pi over 4, pi over 3, or any angle with the same reference angle, right? You have to convert to the actual number, Okay. Now, if I ask you for like tangent of 5 or 7, we don't know that, right? Or like pi over like 1/12, right? At least as of now, right? You don't know how to just directly do that with just a unit circle, so you can leave it as just that. Okay. So this is question 3. Now question 4 asks us to find the exact value of x and y. Now there's a trick. Okay. One trick is that we have a special right triangle. A 45-degree like this, right, means the other angle is also 45 degrees. And this triangle is special because let's say one side's A, right? If one side that's not a hypotenuse is A, that means the other side is A as well, and the hypotenuse is A root 2. A squared plus A squared is 2A squared, right? And what is it? The square root of 2A squared is just A root 2. Now note that tangent, right, of at 45 is sine 45 over cosine 45, which are actually the same values, right? Root 2 over root 2 equals 1, right? But this is also the opposite and the hypotenuse, right? No, sorry, not the hypotenuse, the adjacent. That means both the opposite and the adjacent in a 45-degree triangle are the same. And because they are the same, every time you use Pythagorean theorem, you will just get that small side times root 2. So with this in mind, right, we can say that x equals y equals 70 divided by root 2, right? Because to get this a by itself, you remove this root 2. So this is actually your answer, right? But you can also rationalize to get 70 root 2 over 2, multiplying top and bottom by root 2, and you get 35 root 2 units. So x equals y equals this. Okay? Now the second way you can do this is using trig, right? We can just use cosine, okay? And we solve for y. Cosine of 45 degrees is adjacent, so y equals 70, right? So adjacent over hypotenuse. Cosine of 45 degrees is root 2 over 2. And then you solve for the other one. 70, you solve for y, so 70 root 2 over 2 is equal to 35 root 2, which is y. And from here, this is also 45 degrees, right? With y, you can do Pythagorean theorem again, right? But the square root will be pretty big. So what I actually will do is I will find the other angle and then do the same thing. And let's do sine, okay? Cosine. So cosine 45 degrees this time. The other 45 is x over 70. Cosine 45 degrees is root 2 over 2. And we get x over 70. And once again, we get 35 root 2. That's the answer. So the special case with 45, 90 triangles is really nice to have. But if you don't remember it, good old trig will help you out just as well. Okay, so my question 5. Okay. So we're told that we have negative 24 comma 7 be a point on a terminal side of theta, and we need to find sine, cosine, tangent. Okay, so that means on our graph, we go negative 24 to the left. That's terrible. We go negative 24 over here. And then we go 7 up. And that's our triangle. I can draw a better line. Here, I'm going to cheat a bit. There we go. Okay, now this is the terminal side of theta. What does this mean? It means my theta starts at the x-axis, the positive side, and goes all the way around to this side. The way I remember this is that terminal is like an ending, right? It has to end. So you start on the positive side of the x-axis and you go counterclockwise towards that side, right? If you go counterclockwise, you get a positive angle. You go clockwise, you get negative, but equivalent angle. Okay, so why special right triangles, right? This is 25. This is just a combination you need to remember, or that ends up being remembered. 7, 24, 25. Okay. I want to say that I can prove it, hopefully. I want to say 7 squared is 49. 24 squared, I'll come back to that. 25 squared is 625. So this should be 500. I'm blanking. Is it 76? There we go. Yeah, 576, I think. 24, 24, 96, 48, 576. Beautiful. Okay. And you can see that when we add up the top two, we get the bottom one. So anyways, we need to find sine, cosine, tangent. Now, how do we do this if our angle is outside the triangle, right? So we have a concept called reference angle. We find the angle, the smallest angle from either side of the x-axis to the terminal side. In this case, it would be this angle. So I'll call this phi. Okay. The special thing about a reference angle is that the absolute value of our sine and cosine here is the same as the actual values on quadrant 1. So if you go phi, radians or degrees, like on the right direction, right, from negative x-axis to the terminal side, if you go phi degrees from a positive x-axis, you end up with the same sine and cosine absolute values, right? You can see that we're roughly the same height. If I drew this to scale, they would be the same height. So same cosine. Oh, my pen's so thick. Same cosine. Sine, sorry. Same sine value. And then I'll do absolute value, right? And then the distance, right, from here to here, here to here, we get the same absolute cosine phi value. And this is really neat because that means we now have an angle in the inside we can reference. So we know that sorry, I'm trying to think. So we need, was it sine, cosine, tangent, right? So sine of phi, if we look on this side, right, the all black triangle, we get I'll do like phi 1. Okay. So sine of phi 1 is opposite over hypotenuse, so it is 7/25. cosine of phi1 is adjacent over hypotenuse, so it's 24 over 25. Tangent of phi1 is opposite over adjacent, so it's 7 over 25. But now if we're going to phi, right, if we're going to convert this to the original phi, which is the same as sine of theta, right, note that we're in the positive y region, right? We're in a positive y region, so this will stay the same. But for cosine, right? So cosine of phi1 is equal to cosine of phi. And we, in this case, right, we're on the other side of the y-axis. That means we're negative. That means we need a negative cosine phi, right? That means, which equals negative. Wait, hold on. Let me write this way. This is a little confusing for me to explain. For sine, right, we're on the same side of the x-axis. So sine phi1 equals sine phi. Cosine, right, it's on the opposite side, so negative cosine phi1 equals cosine phi. For tangent, right, we have a positive and a negative, right? So negative, or more easily, right, tangent of phi is equal to sine of phi1 over negative cosine phi1, which is negative sine phi1 over cosine phi1, which is negative tangent phi1. That means our answers become, and this equals sine theta. This is also cosine theta. And this tangent is tangent for theta. So sine theta is equal to 7 over 25 because we don't change the sign. Cosine changes though, so we get a negative 24 over 25 instead. And then tangent, right, also flips the sign, so we get a negative 7 over 24. I just realized I didn't write the right number here. This should be 24. There we go. And these are our answers. Okay, so here we have the same deal again. And this time I'll go a little faster. So we're using 0.38. So 3 comma negative 8. For 3, right, we go left 3. And we go down negative 8. And then here's our hypotenuse. Okay. If I can draw. Okay. Now, for this question, we have to find a hypotenuse manually. There we go. 3 squared plus negative 8 squared is 9 plus 64, which is equal to 73. That means our hypotenuse is square root of 73. Okay. Now our theta in this case, right, goes all the way around. Goes all the way around like that. Right. But again, we can use reference angles. Oh, sorry. Let's just redraw it. Oh, like this. Okay. But again, we can use a reference angle. And we do angle phi. Okay. And if we go the same distance up this way, right, we get a similar looking triangle. let me put this theta like right here. Okay. This free, I'll move it over. And then this is also phi. Right. That means I have a 3 there. I have a positive 8 here and a square root 73, right? But this time I'll just directly solve for the phi here, okay? So my sine of phi, right, which is equal to sine of theta, is equal to opposite over adjacent, right? Opposite over hypotenuse, sorry. So that is negative 8 over square root 73. My cosine of phi equals sine of theta. Sorry, I'm just trying to look at something. Cosine of theta, which is positive 3 over square root 73. And then my tangent of phi, which is equal to cosine of theta, is equal to negative 8 over 3. Sorry. Negative 8 over 3. And why did I rewrote cosine again? What? Tangent. There we go. And those are our answers. All right. So the next question is, given sine of theta is equal to negative 5 or 7, we need to find, and a tangent theta is greater than 0. That means we need to find what tangent is and secant is. Okay, so on our graph, right, we know in quadrant 1, you have plus plus, right? Cosine is positive, sine is also positive. In the second quadrant, you have a negative cosine, positive sine. Third quadrant, negative cosine, negative sine. In the fourth quadrant, positive cosine, negative sine. Now, for tangent being greater than 0, right, that means we need a positive tangent. And that only happens if both sine and cosine are the same sine. That means I'm looking at an angle, right, that's either here or here. Okay. Now, my sine is negative, right? That means if my sine is negative, my cosine has to be negative. That means my final region is this. I don't like that color. It's this orange looking color. Okay. That means my cosine needs to be down there somewhere. So let's draw the triangle, and this is going to be in the third quadrant. So where negative sine, negative cosine live. So I know that my sine is negative 5 over 7, right? That means my opposite is negative 5, and my hypotenuse is positive 7. That means I will go, I'm going to go 7 down, okay? Oh, sorry, 5 down. So we have a negative 5 here. And then if I draw, I have 7. And then we can solve for the cosine length, right? 5 squared plus x squared equals 7 squared. 25 plus x squared equals 49. X squared equals 24. X equals plus minus 2 root 6. Okay. Now we want a negative, right? So we want specifically the negative 2 root 6. All right. Now again, I use sine, right, of theta, and this is my opposite. So I will use this angle as theta. Okay. Now, for tangent, so tangent is just opposite over adjacent, right? So my tangent of theta is equal to -5 over -2 root 6. And this becomes just +5 over 2 root 6. My secant of theta, right, is equal to, and remember, secant is opposite of cosine. So I want my hypotenuse over adjacent. So it will be 7 over -2 root 6. And we can rationalize the denominator. We don't have to because we don't ask to, but we can. And we get 7 root 6 over -12. Right? So this will be -7 root 6 over 12. The 12 comes from the 2 multiplying with the now 6. Okay? And these are our answers. Now for number 4, we have to find our reference angles. Okay? So let's draw each of these angles. Okay, so 330 degrees. Okay, so this angle A, let's do like right around here. Okay, so A is all the way over here. Okay, that means the reference angle is here to here instead, and this angle is just 360 minus 330, right? And that gives you 30 degrees. So we get 30 degrees for the reference angle. Okay, let me draw these like smaller scale. So for part A, we have the main angle. This is 330. And then, oh my god, 330, right? And then the missing angle, the reference angle, is 360 degrees minus 330, which is 30 degrees, okay? For part B, again, another graph. And now, 7 pi over 4. Note that 0 is here, pi is here, right? And 0 is also 2 pi. This is 3 pi over 2, or 6 pi over 4. That means 7 pi over 4 is all the way here. So angle's right here. So 7 pi over 4 looks like this. Okay. And now, our reference angle, right, from the nearest side of the x-axis to the terminal line, we get 8 pi over 4, because that's 2 pi, right, minus 7 pi over 4 equals pi over 4. So the answer for B is pi over 4 radians, okay? You can write pi over 4, but you can also specify the radians if you really want to. It's up to you. I'm just going to put pi over 4 because it's implied to be radians. Now for C, I'll draw it right here. For C, I notice theta is more than 9, right? It's more than 9 pi over 9. So for our angle, I'm just going to assume it's somewhere, let's say like right here. Because, let me think. For 3 pi over 2, right, this would be 13.5 pi over 9. And this is what you get when you multiply by 4.5, okay? So that means my angle is really close. It's like right here. And this is my angle. 13 pi over 9? My reference angle is right here. Oop. Right. And for my reference angle, we'll take the bigger angle this time. So 13 pi over 9. Oh, I should write in red. 13 pi over 9. And we're taking away this portion essentially, right? So this is pi, so pi over 9. And we had 4 pi over 9. So the other two were pretty easy because you're doing a full circle minus the angle. In this case, we want this red line, right? It's essentially part of a small chunk of the main angle, right? But since we're starting at pi, right, we have to take pi away from the big angle, and we get what's left, which is a reference angle. So answer for part C is 4 pi over 9. Okay. For D, okay, we have negative 255 degrees. So 255 minus 180 is 75. So my will be like right here. Okay. And my angle this way is negative 255 degrees. Negative 255 degrees. If you don't remember how to do negatives, right, you can add 360, because if you add a circle, right, one full circle, you're back where you are when you just move the circle, right? So negative 255 plus 360 is equal to 105, right? I shouldn't. Oh, yeah. The reason for this was for me to estimate where I am, right? So it's 180 degrees plus 75 more. And you might have noticed that 75 is actually my reference angle. But anyways, from here to here is a positive 75 degrees. Okay. Either way, find this angle, right? You know that the distance from here to here, right, is 180. So actually, this equation will work quite well again, right? 255 minus 180, and that's your reference angle, the 75. Or, this is not 75, this is 105, sorry. Where 105, right? What you can do this time is, you can see that, the 105, my blue angle and my red angle are supplementary, sorry. They add up to 180. So in this case, you can do 180 minus 105 equals 75 degrees. So either way, you get the same answer. You don't have to draw the angle to scale, right? I'm trying to eyeball it for your visual, but you don't remember, just kind of draw it some way, right? The important part is you understand how to subtract your big angle. So like it's either be 180 or 360, right? And the angle you have. So you notice all my calculations, right? I have a 360, there's the 2 pi, same thing, right? It should be 9 pi over 9, sorry. This is my 180, right? 180 again is my 360, 180, right? So it's a lot of adding or subtracting from 180 and 360 to the reference angle. Okay. So the answer for part D is 75 degrees. And there you go. That is question 4D. And with that, this concludes my video on trig functions. Thank you for watching.